Here is an electric vehicle, all-wheel drive, a passenger car, that has a rather pronounced tire resonance, and we would like to evaluate perceptually what happens if we cancel the resonance. That's one point. The other point is that by using our eyes and a spectrogram versus time, like an FFT versus time or RPM, we can visually cancel the resonance and have it be exactly the same as the information on either side of it in frequency, thereby also being able to measure it to find out what is the bandwidth and what is the magnitude. So I'm going to calculate this to an FFT versus time, to a mark analyzer. There it is. Incidentally, we see there is a tonality which is modulated. We see these vertical beads, little stripes, and this, if you were to listen to it, goes whoa, 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 like that, and we can evaluate that by other means. But here is the tire resonance. Once you're in the vehicle, once you are aware of it, it becomes very easy to hear all the time. So we can play, and again, bring the cursor, and you can hear that modulated tonality that I mentioned. Let's pause right here, and let's get the playback filters. This is a constant frequency filter, and let's magnify our screen axis vertically frequency so that we can kind of see better and get the numbers better. So if we position a filter over this and then turn it on, double click, it has a certain amount of attenuation, which is too much. So if I roll the mouse toward me, I get more attenuation. If I roll the mouse wheel away, I get less. I believe I have too much bandwidth. So if I hold down Control and roll the mouse away, I get a narrower band, and then I can start reducing the attenuation. The idea being to make this region look like everything else and to move up and down. Now I'm a little bit too narrow in my bandwidth, so I'll back up like this and play again a little bit with the magnitude. And if we move away from having the cursor over the marker, then the line disappears, and that helps us to evaluate what's going on. So let's continue our playback and turn this filter on and off. I'll drag the filter of the playback closer to the action. Filter on, off, on, off, off. And that's back on. So we can read here that we have a Q of 8.78, basically 8 3/4, and we have about a 10 dB magnitude of this resonance. There can be multiple resonances. There can be very narrow band ones. You can use this method to use your eyes and the spectrographic capability of the computer to be able to cancel visually, make it the same as the surroundings, and then evaluate what would it sound like if the resonance weren't there, and exactly what is the resonance doing. I like, with a playback filters tool window, before I do the next thing, when I finish using it for something, to set the filters back to their defaults, which are 62.5, 125, and 250 hertz, with a 6th order slope and a certain Q, an attenuation of 24 dB. So you can individually for a filter save and recall, and you can set and save and recall a group of them. The default has 3 filters. You can always have more, but for the original 3, go up here and click on this little colorful icon and ask for the default 3 and hit the check mark. And you are now back to normal. Then close, never hide, because you can accidentally hide it and leave filters engaged that you don't realize are on and get into trouble. So anyway, we have a completely clear off, reset playback filters and completely close it.